Hello once again, ladies and gentlemen. Welcome to our virtual classroom. Today's lesson is going to be on lesson 17-2, which is proportions. Once again, I encourage you to pause the video right now and copy the notes so you can just have them in front of you as I go over them and add on to them as well. And of course, at any point during this recording, feel free to pause the video, rewind, fast forward through things that you feel you already got down um, to make a better use of this resource. Anyways, assuming you've already copied this down, let's talk about proportions. And I think a better title for this lesson would have actually been proportional relationships. Proportional relationships. I just shortened it to proportions. And really, when we're talking about proportional relationships, we're talking about equivalent ratios. Equivalent ratios. Now, don't let the word ratio catch you off guard. We did cover that just recently, and ratios can be expressed as fractions. So really, when we think of proportional relationships, just think of equivalent fractions, which takes us back to fourth grade, I think. Fractions, equivalent fractions. What do I mean by that? Well, consider this list of fractions right here. Okay, all of these fractions are equivalent. Each one of these fractions is equivalent to all others within this list. For example, consider the fractions 2/3 and 4/6. All right. Now, two different ways that you can tell that these fractions are indeed equivalent is number one, notice that if I multiply 2 by 2, in other words, I increase it by a factor of 2, that gives me 4. And if I do the same thing to the denominator, multiply by a factor of 2, that gives me 6. Anytime, ladies and gentlemen, you increase both the numerator and denominator by the same factor, the resultant product, the fraction that you get, is going to be an equivalent fraction. So in this case, we can see that it is equivalent. Now, another thing that you could do is also cross multiply or employ what we know as the butterfly method. So if I do 3 times 4, that gives me 12. And then if I do 6 times 2, that also gives me 12. Ladies and gentlemen, when you cross multiply fractions, if they give you the same product, you know that these two fractions are equivalent. If you do that to any of these two fractions, if you got any two of these fractions and cross multiply them, you will find that they give you the same product. They're all equivalent to one another. So whenever you have this, a group like this of ratios of fractions, you can say that these are proportional. This represents a proportional relationship. It doesn't just have to be going up, but also coming down. Notice that if you take 50 and you divide 50 by 2, if you divide 50 into 2, that gives you 25. If you do the same thing to 100, you decrease it by a factor of 2, you get 25/50ths. They are proportional. It is a proportional relationship. Same thing with 10 divided by 2, you get 5. 20 divided by 2, notice how in both you're decreasing by the same factor, a factor of 2. Over here, I'm decreasing by a factor of 5. If I divide this by 5, again, it gives me the next fraction. Look at this one in the middle, though. 25 over 50 and 10 over 20. 25/50ths and 10/20ths. Now, it's obvious that you cannot, I mean, 10 does not fit into 25 evenly, okay? You can't multiply 10 by any whole number to get 25 or 20 by any number to get 50. However, these are still equivalent fractions, and I know that for two reasons. Number one, if I cross multiply them, 50 times 10 will give me 500. And 20 times 25 will also give me 500. Therefore, ladies and gentlemen, I know that these two are equivalent fractions. Also, if I simplify each of these, you're going to see that they both simplify to the same fraction. They both simplify to 1/2, meaning that they are equivalent fractions to each other. All right, so don't expect them to just always be able to increase or decrease by a whole number factor. All right, and that's the essence of this. This is something that again, it should be reviewed, something that you probably have seen before. So with that in mind, let's go into our textbook and go to number 3. And I encourage you to continue on in your notes with number 3. And if we go to our textbook, let's begin there with number 3. Let me just erase all this. All right. So number 3, I do want you to take a moment to pause the video and copy down this table right here. Once you finish copying it down exactly as it is, come back. And so let's continue. So number 3, it reads, the recipe for a homemade hot dog, no, sorry, the recipe for a homemade dog treat calls for a mixture of 2 eggs for every 8 cups of flour. So notice that those are my 2 variables, eggs and cups of flour. All right, and so in this table, notice that they, which is known as a ratio table, they already kind of filled in the 2/8 for us. We have 2 eggs for every 8 cups of flour. Now, ladies and gentlemen, let us treat that like a ratio, like a fraction. We have 2/8, 2/8, right? Okay. Well, if you've ever baked anything or followed any kind of recipe or watched somebody do that, you know that sometimes you want to make more or less of a batch. Okay, you're not always going to do exactly what the recipe says, but you want to follow the same ratios. You want to still follow the same instructions, if you will. And so let's suppose that you want to make more dog treats, and in fact, you have 6 eggs with you, and you ask yourself, well, how many cups of flour am I going to need? In essence, guys, we're taking 2/8 and we're asking ourselves, what is an equivalent fraction that has a numerator of 6? What does a denominator have to be? All right. Well, ladies and gentlemen, let's remember we have eggs on top and we have cups of flour on the bottom. So what do I have to do to 2 eggs to get to 6 eggs? What factor do I have to increase it by? Well, that would be a factor of 3. Now, if I want to create an equivalent fraction with a numerator of 6, then I have to increase the denominator by a factor of 3 as well. So 8 times 3 is going to give me 24. In other words, ladies and gentlemen, 6/24 is equivalent to 2/8. This is a proportional relationship. Let's do the same thing. Let's continue. Let's keep working with 2/8. Let's keep working with 2/8. So we have 2/8, and now let's say that instead of having lots of eggs, you have tons of flour. You have 40 cups of flour, right? And you're asking yourself, well, if I have 40 cups of flour, how many eggs am I going to need? All right. Well, let's do the same thing. We need to create a proportional, or rather equivalent fraction with 2/8 that has a denominator of 40. So 8 times 5 is equal to 40. So it's going to increase by a factor of 5. So that means that I have to increase the numerator by a factor of 5 as well. 2 times 5 is equal to 10. These are now equivalent fractions. We're continuing with this proportional relationship. Now, 6/24 and 10/40 are also proportional. They're also equivalent. But the reason I didn't use a 6/24 is because 24 times, there's no whole number that I can multiply 24 by to get exactly 40. If you went ahead and multiply these, 24 times 10 is 240, and 40 times 6 is also 240. So they are still equivalent, but they just it's just not as neat. It's not as obvious as 2/8 is. Okay. So let's continue with the next one. Okay, well, what if you have 64 cups of flour? If I have 64 cups of flour, well, I can multiply 8 times what to get 64? I can multiply 8 times 8. So that means I can multiply 2 times 8 as well. And 2 times 8 is going to give me 16. And remember, I can also go backwards. Okay, well, what if I only have 1 egg? Can I still make the dog treats? Well, of course, just divide 2 by 2 to get to 1, and 8 divided by 2 is going to give me 4. As long as you're doing the same thing in both instances, that is going to give you a Well, the same thing, either multiply or divide. That's what I meant by that. That's going to give you an equivalent fraction. And we have just successfully completed our table, which means that now we can answer these questions. For example, and by the way, on Schoology, if you are submitting this, know that for 3A, all we're doing is just putting in what we got for the table. In fact, if I were to start over, just click on the blank to see what part of the table you're on. Here I have number of eggs and cups of flour. For 1 cup, from 1 eggs, 2 eggs, 6 eggs. And right here, we know that for 40 cups of flour, we needed 10 eggs. For 64 cups of flour, we figured that we needed 16. I'm just copying what I got from my table. For 1 cup, for 1 egg, we needed 4 cups. And for 6 eggs, we needed 24 cups. All right, so that's pretty simple. The rest, how many eggs are needed with 40 cups of flour? Okay, well, 40 cups, we need 10. Simple. How many cups of flour are needed with 6 eggs? 6 eggs, 24. We figured that out. Look at D though. It says use the table to name 4 ratios equivalent to 2/8. Remember, each of these represents a ratio. 2/8, 1/4, 6/24, 10/40, 16/64. Ladies and gentlemen, all of these are equivalent. So 4 ratios that are equivalent to 2/8 would be 1/4, 6/24, 10/40, and 16/64. So even though this is not one of the questions that we have for Schoology, you're not going to find D on Schoology, I do want you guys to know that because we created equivalent ratios, of course, all of these are going to be equivalent to each other. And finally, for E, write a ratio that is equivalent to 2/8 in its lowest form. So 2:8 is the same thing as 2/8. Well, the smallest version of that is going to be 1/4, which is the same thing as 1:4, which again we got from our table. As you can see, ladies and gentlemen, there's nothing really crazy about this, right? For number 4, we're going to do the same thing. Let us do the same thing for number 4. So I encourage you to pause it as you copy down this table. And it reads, for every 4 days of dog sitting, Julie charges $20. So we're comparing now days to dollars, and our days is going to be the x-axis, and our cost or what she's charging is going to be our y-axis. Okay, after you copy the table, notice that they already gave us the relationship 4/20. 4 days is $20. Let's continue filling the table though. So what if we double that? What if instead of sitting for 4 days, she dog sits for 8 days? In other words, we increase it by 2. Well, we have to increase the denominator by 2 as well. 20 times 2 is 40. Well, what if instead of dog sitting for 4 days, she dog sits for 2 days? In other words, we divide it by 2. So 4 divided by 2 is 2. So 20, we have to divide that by 2 as well. It's going to give us 10. And if we divide by 2, once again, 2 divided by 2 is 1. 10 divided by 2 is 5. We followed the exact same process as what we did above there. And so having this table, this is what I really want to focus on for this example. Notice again that the number of days is the independent variable. I know we haven't talked about that since before Christmas, but if you remember, there's an independent and a dependent variable. The independent variable is going to change or affect the dependent variable. In this case, we have days and cost. Okay, the cost that she charges is going to depend, that's the dependent variable, on how many days she's actually dog sitting. It's not the other way around. All right, and so on my graph, my independent variable is on the x, that's going to be on the bottom. I have it over here on this graph already. And my total cost is going to be my y, which I have right here already. And so what I did is I just simply plotted that, okay? For 1 day, that's an x of 1. The cost was 5, so I go up to 5. So right here, I'm going by 10, so it would go right here. Let me do it in a different color. Blue's fine. Let's do orange. Okay, for 2 days, she's charging 10. For 4 days, she's charging 20. And for 8 days, she's charging 40. So ladies and gentlemen, I have just graphed this, but what pattern do you notice? What pattern do you notice? In fact, if I were to make a law to join all of these, notice that they make a pretty much a perfectly straight line. It's a little off, but that's just because the screen warps it a little bit. But it's essentially a perfectly straight line, right? And not only is it a perfectly straight line, but that line is crossing here at this point, which would be 0x, 0y, which is known as the origin, right? We should know that already. That is the origin, right? And so the reason why that is important, ladies and gentlemen, is that, remember, this is a proportional relationship. We made sure of that. Okay, we increase or decrease by the same factor each time. So we know that this is a proportional relationship. And when I graphed the proportional relationship, two things happened. Number one, we got a perfectly straight line. And number two, that line is crossing through the origin. All right. Now that is always going to be true of proportional relationships. If you ever graph a proportional relationship like we just did, or like what you would get if you graphed the first chart that we did, ladies and gentlemen, two things are going to happen. And I do want you to write this on your notes. So if you go back to your notes and just add it to at the very top where we wrote proportional relationships, I want you to write the following. The graph will, meaning the graph of a proportional relationship will always, number one, be a straight line. And number two, not only will it be a straight line, but it will cross at the origin. If you were to extend the line, it would cross at the origin, which is the point 0, 0, 0x, 0y. Okay, please pause this if you have to, write that down. The graph will always be a straight line, and it will cross at the origin. What do I mean by that, though? Well, consider the fact that on some graphs, you're going to get graphs that are perfectly straight lines, except that they will not cross at the origin. You might see something like this, or you might see something like this, or you might see something like this. It's close, but not quite. All right, they're straight lines, but they're not crossing at the origin. That is possible. Also, it is possible to have a line that looks like it's straight, it's crossing through origin, but then at some point it deviates. It's not always straight. All right. These do not represent proportional relationships, ladies and gentlemen. Now, you might also have the graph of something that is crossing at the origin, but is not a straight line at all. It might be something like this, or something like this, like where it crosses, but it's like that. So ladies and gentlemen, again, it has to be a perfectly straight line, and it will cross at the origin. And that's just something you need to know. You need to know for now. All right, so that takes care of B. And C asks, is the relationship between the number of days and cost proportional? Yes, it is, because all of these ratios are equivalent, so it is proportional. And not only that, but when we graphed it, we had a straight line that crosses at the origin. So it is proportional. That's not on Schoology, but that is just for you to know. All right, D, use your graph to determine how much Julie should charge for 6 days of dog sitting. Now, you don't necessarily need to use the graph. You know, if I use any one of these ratios, let's use 1/5. Remember, 1 is the days, and then the 5 is the cost, days and cost. Well, what if you dog sit for 6 days? Well, what's going to be the cost? Well, you can just multiply 1 times 6, increase 5 by the same factor. 5 times 6 is 30. Ladies and gentlemen, she should charge $30 for sitting for 6 days. The graph shows that as well. Look, if I go to 6, it's going to go meet the line right at 30. So yes, that totally works out. It's the same thing. Finally, for E, and then questions 5, 6, and 7, you're going to do the same thing. They're going to give you two ratios, and they're asking, are these equivalent? Well, ladies and gentlemen, you're going to find that in all of these, you won't be able to increase by a common factor that is a whole number, but you can always still cross multiply. 20 times 10 is 200. 50 times 4 is also 200. So therefore, ladies and gentlemen, this does represent a proportional or an equivalent fraction. You're going to do the same thing for 5, 6, and 7, where you're just going to cross multiply and ask yourself, do they give me the same product? And if they do, they are equivalent, they are proportional. If they do not, then they are not proportional. All right, ladies and gentlemen, hopefully that was helpful. Hopefully this was just a good review. Yeah, if you have any questions, feel free to email me or message me on Schoology. And having said that, I will see you next time. I'm having a hard time ending this. Give me 1 second. And okay, we'll see you next time.